Welcome back to day 4 of our final exam review unit. All right, today our goal, given a linear equation or inequality, you will be able to solve and then graph. So let's take a look at solving our linear equations first. All right, here we have 3 linear equations. Each one's going to use a different technique. So all 3 of them have the directions solve for the value of x. So let's take a look at the first one. So here, if we take a look at this, the first thing we have to do is get rid of the parentheses. So we know that there's no number there, it's really a 1. So we're going to take this -1 and we're going to distribute it into the parentheses. The first 7x stays the same. Now -1 times 2x becomes -2x. -1 times -6 becomes +6 equals 36. Now, once we have this equation, we're going to combine our like terms and solve. So here we get 5x plus 6. We're now going to transpose the 6 to the other side using subtraction. 5x is equal to 30. So then x is equal to 6. All right, now let's take a look at example number 2. Now, I'm going to show you a neat method here, but it can only be used when you have a fraction equal to a fraction. Okay, I repeat, it only works if you have a fraction equal to a fraction. So let's take a look here. When we have that, we're going to take all of our binomials and we're going to put them in parentheses. Remember, a binomial is a quantity and quantities go into parentheses. Now the trick is, we're going to use what's called cross multiplication. So I'm going to take the top of the first and we're going to multiply it to the bottom of the second fraction. So this is 3 and minus 5. And then we're going to take the bottom of the first and multiply it to the top of the second. Once we do that, now there's no fractions anymore. So you cross multiply to get rid of the fractions, and now all we have to do is distribute and solve. Okay, then I'm going to subtract the 2n. I'm going to add the 15. 2 n's cancel, 15's cancel, so we get n is equal to 25. Okay, next, I'm going to try an equation where there is fractions. I know this gives everybody the heebie-jeebies, all right, but it's okay. Remember, fractions are just numbers. So let's go ahead and if we take a look here, just like we did in the first problem, we're going to distribute. So 7 over 3 times x is going to be 7x over 3. All right, plus, now I'm going to take 7/3 and I'm going to multiply it to 9 over 28. And I'm going to let the calculator help me out here. So 7 divided by 3 times 9 divided by 28. And look at how handy-dandy that is. We end up with a rational solution. So we have a decimal that terminates. So we're going to just write it as a decimal equals 20. Now we're going to go ahead and solve. So I'm going to subtract 0.75 from both sides of that equal sign. All right, so we get 7 over 3x equals 19.25. Now, to get rid of the fraction, we're going to multiply by the reciprocal. So the 3's cancel, the 7's cancel, we get x is equal to, and now 19.25, and then we go 3 divided by 7, and our final answer is 8.25, and we have our solution. Okay, so that's solving linear equations. Now let's take a look at linear inequalities. So no longer are there equal signs, now we have inequalities. All right, so we're going to solve using the same strategies we did above. We're going to get the x alone by transposing. So if we take a look here, the first thing we're going to do is we're going to subtract 6. And we get -2x is greater than or equal to 6. Now we're going to divide by -2. But wait, error, error, error. All right, be very careful here. We are dividing by a negative. When you divide by a negative, you have to take this inequality symbol and you have to flip it. So instead of greater than or equal to, now it's going to be less than or equal to. And again, it only happens when you divide by a negative. So now we have x is less than or equal to -3, our final answer. Okay, up next, if we take a look at number 2, this one's a little bit different because instead of one inequality, now we have 2. If there's 2 inequalities, that means there's really 2 questions here. So we're going to divide this into 2 questions. So -7 is less than x plus 2 over 3, and x plus 2 over 3 is less than 5. So the middle goes with both. All right, so now we're going to solve. So the first thing we have to do is get rid of that 3 on the bottom of the fraction. So I'm going to multiply both sides by 3. So I'm going to get -21 is less than, those 3's cancel, x plus 2. Then we subtract 2. So -23 is less than x. Now on the other side, we're going to once again multiply both sides by 3. And then those cancel, so we get x plus 2 is less than 15, and we subtract 2 from both sides. So x has to be less than 13. Now I can leave this as 2 or we combine it back to 1 because if you look, the x is going to be right here in the middle. So we have 13 and -23, and that's our final answer. All right, now let's try some exam style questions with our inequalities. So let's take a look here at number 3. Given 2x plus ax minus 7 is greater than -12, determine the largest integer value of a when x is -1. So we wanted the value of a when x is -1. So I'm going to take this -1 and I'm going to replace the x with a -1. So 2 times -1 plus a times -1 minus 7 is greater than -12. So let's go ahead and multiply. So -2 minus a minus 7 is greater than -12. Now I can combine my -2 and my -7. So -9 minus a is greater than -12. So I add 9. So -a is greater than -3. So we divide both sides by -1. Error, error, error. Once again, we're dividing by that negative. So we have to take this inequality symbol and we have to flip it. So now it's going to be a is less than +3. Okay, now let's go back and make sure that we answer the question. Determine the largest integer value. Remember, integer is a positive or negative whole number. So what's the largest integer that a can be if a has to be less than 3? Well, if it's less than 3, it can't be equal to 3. So the largest integer is going to be 2. And we've got it. All right, now let's go ahead. I'd like you to pause the video and try question 4 on your own. All right, here we go. I got x is greater than 15. If x is greater than 15, it can't be equal to 15. So the smallest integer that it could be is 16. All right, now let's change gears. Now that we know how to solve, let's take a look at graphing our inequalities. So number 5, solve the system of inequalities graphically. Oops, can't see that. Solve the system of inequalities graphically. So the first thing we have to do is we have to make sure that we put our line in standard notation. So we got to go ahead here and we're going to divide by -3. All right, so when we do that, we end up with y, but careful, error, error. Once again, we're dividing by negative, so we have to switch this inequality symbol. All right, so now instead of greater than, it's less than or equal to -2x plus 6. A negative divided by a negative is a positive. So now we have our equation in standard notation, which is y equals mx plus b. So let's go ahead and let's graph. So here we're going to start at 6. Now our equation is -2, so we're going to go down 2 over 1, down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. Okay, now we can draw our line. Now, if we look carefully here, this is less than or equal to. Since you have that extra line underneath, it can be equal to it, which means this is going to be a solid line. So I'm going to draw this as a solid line. Okay, and then we make sure that we label it one of our arrows. But remember, since this is an inequality, we have to shade. Now, y is less than, so since it's less than, we have to shade down. So put your pencil or pen on the line, and we want to shade towards the bottom of the page. So this is towards the bottom. So these arrows are going down towards the bottom of the graph. All right, now we go to our second line. So here we have y is greater than 2. Now this is already standard notation because the y is by itself. Now if you forget how to graph this line, we can go to our y equals, type in 2 and hit graph, and we see this is going to be a horizontal line across our graph. So I'm going to come over here, I'm going to put my ruler at 2. Now be very careful, we have to realize this is a solid or a dashed line. Well, there's no line underneath there, so that means it's not equal to, it's just greater than. So we have to do dotted. Y is greater than 2. Now, since the y is greater than, that means we shade up. Okay, so graph the system was part 1. Part 2, label the solution with an S. So I'm going to put an S there. Okay, and then part C, state a point that makes neither equation true. So neither equation true means there's no shading. I'm going to come over here and I'm going to pick 8, -2. And we've got it. All right, so now that we've reviewed how to graph, okay, how to solve, let's go ahead and let's take a look at an inequality in a word problem. So let's take a look here. So we have Caden and Riker washed cars to make some extra money. At the beginning of this year, Caden had already washed 24 cars. He continues to wash cars and washes 15 cars each month for a year. Riker is new to the car washing business, so he only had 12 cars at the start of the year. Riker is able to work more quickly, so he can wash 12 cars each month for a year. Write an inequality that could be used to model the situation showing when Riker would have washed more cars than Caden. Okay, so there's a lot of information up here, but first you need to think, what is important? What am I trying to do in this problem? I'm trying to show when Riker has more than Caden. So I want Riker to have more. I want him to be greater than Caden. Okay, now that I know what we're trying to do, now I'm going to go back up to the top and I'm going to reread for my important information to see if I can create inequalities to put underneath these two gentlemen. So let's take a look. At the beginning of the year, Caden had already washed 24 cars. Okay, so here we're working with Caden. He had already washed 24 and he washes 15 cars each month for a year. So each month he's going to wash 15 cars. So that means 15 is the number we're adding every month. So that's going to get the X next to it. And 24 is what he started with, his starting value. So we just add that on. Now we go to Riker. He's new to the business, so he washed only 12 cars. Okay, and he is able to wash 20 each month. So 20 each month plus he started with 12. So now we've written our equation. So part B, during what month during the year will Riker have washed more cars than Caden? So now this is actually asking us to solve the inequality. So we can come down here, 20m plus 12 is greater than 15x plus 24. So we can go ahead and solve. Oops, I'm sorry. What did I do up here? I put 2 variables. We only want 1 variable. So I used x over here as months. So I should also be using x here for months. I apologize. So this should also be an x. We only want 1 variable here because they're working the same months every year. So we're going to go ahead and we're going to change that and make that an x. So now we can combine our like terms and transpose. So we're going to get 5x plus 12 is greater than, and we have over here the 15's canceled, 24. So now we subtract 12. So 5x has to be greater than 12. So now let's take a look. So 12 divided by 5, and we get 2.4. So x has to be greater than 2.4. So we need to think, well, what